How many of you think that architecting, building, testing, deploying, and monitoring your applications have gotten easier in the last 10 years? Come on, show of hands, everybody, right? Really? There are hands going up? Our applications are getting so complex, and it's mostly because of the architectural decisions we've made over the years. Cloud, microservices, it means we have more components, running in more places, with more languages, talking to more things. There's a lot of complexity. So hopefully what you get out of this today is that there are some tools in your tool belt, if you're not using today, that maybe you can start using here in the near future. My name is Judd. I'm the CTO and a partner at Manifest Solutions. We're a mid-sized consulting company right here in Columbus, Ohio. I do architect and implement AWS solutions on a regular basis. I develop and teach customized AWS training. I have a lot of experience in that. I'm also a Java champion, so most of the work I like to do is it happens to be in Java. And when I'm not writing code, I tend to write words, so I've co-authored some books and even a children's book. So the main topic we're talking about right here, just to make sure we're all level set, I have a couple definitions to make sure that we're talking about the same things, is observability. And what is observability? It's the measurement of how the inner state of some system, our applications, are working from an external perspective. And I like to think of it much like a doctor. My son broke his wrist a couple of years ago. The doctor didn't slice open the arm to see if the bone was broken. They used x-rays and viewed it from externally. And if you haven't seen the acronym, the O11Y is observability. So letter O, 11 characters, and a Y. What are the pillars of observability? There's 3 of them. One is distributed tracing. That gives us the ability to watch a transaction or request go from the client through all of those components I talked about, all the microservices, all the cloud components, all of your lambdas, all the data stores that you're talking to, so you can follow that entire path. We also have metrics, and we have logs. So the combination of those 3 are what we can observe from an external perspective of our applications and our systems. And then the definition of telemetry. Telemetry is the in situ collection of measurements and other data from remote points. So I like to think of this much like dealing with sensors. So we are going to have sensors within inside of our application, collecting those 3 different pillars, aggregating them into one common location that we can then monitor the applications in one place. What are the types of telemetries that we might gather within our application? Well, you're probably looking at how your application is performing. Is it performing slow? Are you having network-related issues? Are there certain parts of your application that aren't performing up to speed? Are you not getting that whole budget of performance across all of your different components? Is your application failing? Are you having crashes? Are you getting exceptions? Are there some reasons why those requests aren't making it back to the end user? General statistics. Do you have enough disk space on your systems? Is there enough memory on those systems? Are your CPUs a little too hot? Feature usage. Do you have users actually using certain parts of your application? Or did you build them and they never get used? User behavior. How did the user interact with the system? Did they go from point A to point B every single time, or do they use different choices? Hardware statistics, I already talked about that a little bit. And then from a security standpoint, you might also be collecting information about threat detection and intrusion, all underneath that telemetry umbrella. Now, some of you are probably saying, Chris, we already know that AWS has observability. It does. It captures metrics, it captures traces, and it can capture logs as well. And it uses 2 primary things to do that. It uses CloudWatch, and inside of CloudWatch it's going to collect your metrics, give you the ability to create dashboards for it. And I'm sure you've all seen the logging that it captures in your log groups and in your streams. And then for the distributed tracing, it uses X-ray to capture that type of information. And you're probably thinking, Chris, this is really easy. We already have this problem solved. There's a checkbox. I go to my admin console, I do the checkbox. I go to my CloudFormation, add true to a property, and now I have my X-ray and I can watch everything going on within my application. I get these nice trace maps where I can see how one component calls another component. I get these lists of traces that I can look at, and I can look at the traces and then see where was all the time spent in a single request, what components were involved, what part of that time was allocated. Like I said, I might have dashboards that I can look at to see what those metrics look like. And all of that is built into AWS, and hopefully you're probably using that already. But if you are, let me make sure you realize you have blind spots. If you have any complexity in an application, there are things that you are missing that you are not seeing in those traces that AWS doesn't know about. And that's why we're here today. At least that's why I'm here today. So examples of those blind spots is you can't see what's going on in the client. If your client's not running inside of AWS, so you have an Angular app, you have a React app, you don't know what's going on there inside of on these dashboards and these components that have been provided for you. If you have parts of your applications that are running on-premise, I work at a client where we have stuff being called on APIs that are on-premise because they don't want that data outside of their data center, or they have security constraints around how they're doing stuff. Anything on-premise, you don't have a visibility into this dashboard. You may know that a call was made there, but if the performance problem is in the on-premise component, you can't see that either. And depending on the complexity of your application, if you're deploying to ECS, EKS, EC2 instances, you might have a full application that has a full stack of controllers, and the controllers called services, and the services called repositories. And it may also call other APIs. Where is the performance problem inside of that component? These are all places where you have places that you don't have full visibility into. So I want to help you fill those blind spots. Now, one option you have is AWS does provide SDKs and components and agents in order to do that. So there's a list of them. You can incorporate those. There's nothing wrong with that, but if you are building components that are deployed, and I'm going to focus on ECS and EC2, if you have large applications that you're deploying to those, you might not want to tie your application to AWS, because if you did, you might not be running it in containers or on a virtual machine. You want it to be runnable locally. You might want to make sure that in the future, if you migrated away from AWS, you still have the opportunity to run that application. So by incorporating most of these solutions, you have coupled yourself to AWS in a way you may not want to. So what I'm right here to recommend is OpenTelemetry. And I'll explain what OpenTelemetry is in a minute. But you can see of this list of components provided to you by AWS, they also use OpenTelemetry as one of those major components. So what is OpenTelemetry? Well, it's a open source project, 100% open source. Everything is free and available for you to use. It is a part of the Cloud Native Computing Foundation. So it's a very large consortium providing tools for you in a lot of different ways in the cloud space. And really what OpenTelemetry is it's that open source project that provides APIs, libraries, and agents for you to collect the data we've been talking about, to collect traces, metrics, and logs in an independent way. Now, I think this is important because when I first started learning about OpenTelemetry, which I was trying to solve a problem that it surprised me we didn't have really great solutions for up to this point, there were some point solutions that could solve the problem, but nothing that was independent. Everything was tied to a particular vendor product, whether you were using the AWS Cloud Solutions, New Relic, or some of the open source solutions. They all understood their APIs and stuff, but that caused other points of blind spots. Not every tool understood those. The thing about OpenTelemetry is it's not a server solution. It's not a vendor solution. It's a level of abstraction on top of those products. So your application can know about OpenTelemetry, but it doesn't need to know about the underlying vendor products and solutions. And no surprise, it collects those three pillars of observability that we talked about. Now, this project's been going on for several years. If you haven't heard about it, You might be wondering, where did this come from? Or maybe you have heard about it and you're like, well, I'm not sure it's stable because it's relatively young. It was a combination of multiple open source projects. And because of that, each pillar of observability is at a little bit different stage of development. At this point, they're all considered stable. And you have to look at from all three components I talked about, the API, the SDK, and the protocol. So all for tracing, metrics, and logging, they are in a stable position. They are considered 1.0, ready to be used in production. But then at the API level, an API is implemented in multiple languages. So not all languages are in a stable position as well. So this is true as of release 1341. And on the next slide, I have a URL where you can go look to the matrix for your particular programming languages that you might be incorporating this in to see what level of stability do each of those have. So this is, if you want to go look at your language in particular, you can go find out what stage that they're in. And like I stressed before, OpenTelemetry is a library or an API that sits between your application and vendor products, but they're vendor neutral. So you can switch out the vendor products later on. And this is a list of some, not even all of the vendor supported products. And this is what differentiates it from previous solutions of collecting this observability information. And there's a lot of interesting ones. There's a lot of vendors here: AWS, OpenTelemetry, or New Relic, Zipkin, open source ones like Prometheus. But you also have ones that are not vendors, like F5. So F5 is a network entry point. And I know that I've had to try to debug performance problems, and we would have to get PCAP files from F5. A lot of fun to try to correlate that to a request if you've ever had to do that. But they support the ability to capture this information and put it into the same repository with the rest of your applications, making that much easier than other ways of doing it. And of course, AWS is on that list. So they're one of the vendors that can be supported as well. Let me talk real briefly about what does the architecture look like for OpenTelemetry. So there's 4 main components. At the top level, what we have is the APIs and language independent protocol interfaces. So that's how they can support all those different languages. And it describes the semantic in the protobuf languages and APIs for the 3 different pillars, as well as a trace context. This context is really important because you want to know when the user clicks on the button on the front end, how does that go all the way to your back end and back? It's this trace context and how it gets propagated that is how that works. And so this describes all of those interactions up there. It also describes a protocol for all those components to talk to each other. It's called the OTLP, or the OpenTelemetry protocol. Then below that, we have the SDKs, and this is a library you can download in a number of different languages from the OpenTelemetry library. This is what abstracts you from the vendor. And I'll also say that the vendors love this as well, because the vendors don't really want to be writing all these libraries in all these languages to support all your needs. They'd rather have one solution, and then they can focus on what differentiates them on the back end. And so you can see a lot of the supported languages that they have, and you install that library in your application, or they often have agents that can self-configure themselves, and I'll demonstrate that in a little bit. Then there's a component called the collector. So instead of having your application talk directly to the vendor, you can have a collector which can also improve scalability. It can translate stuff, it can reformat stuff, it can batch things. So this is a very important component as well. That takes the information from your application that the library sent to it, and then it forwards it on to the vendor products that I demonstrated on the previous slide, again, including the AWS X-Ray and CloudWatch. Bless you. So this is what a basic architecture would look like using agents. You'd use a library inside of your application. It would collect the metrics, the distributed tracing, the logging, sending it to the collector that sits in the middle, and then that collector can be configured to write to one or more different backends. So the other advantage is you're not tied to one vendor in the back end. So if some of them are stronger in some areas versus other areas, you have that flexibility. So you also have the flexibility if you're running it locally as developers, you could be using open source components that give you some of the same type of feedback, but maybe in production you're using a commercial vendor or you're using AWS as your cloud provider. And you can imagine a day, since every other talk but mine, it feels like, is artificial intelligence here, you could imagine an artificial intelligence backend at some point in time being able to come online and predict what outages you may have in the future. You don't have to make any changes to your application, just a little bit of configuration on that agent collector, and now you're writing to a whole new source, giving you all new capabilities. The way all of those communicate is under a number of protocols, the OLTP protocols that can use gRPC or HTTP. And because of this collector, you also have the ability to scale it up. So if you have EC2 instances that are running multiple components, or you wanted to do a sidecar in ECS or Kafka, or not Kafka, Kubernetes, you can have an agent run closer to those components, collect the data, and forward it on to another agent, which we would call a gateway collector. Same exact component, just slightly different configurations. Now you're probably thinking, Chris, this is great. You told us a lot about OpenTelemetry. What does this have to do with AWS? Well, if we look at this, what we can see is not only can we collect it with those two, but AWS provides its own collector. And this collector is the ADOT is what I refer to it as the AWS distribution of OpenTelemetry. So they've taken the open source collector from OpenTelemetry, made that available to you with some additional extensions, and those extensions specifically know how to talk to the AWS services, writing to CloudWatch, and writing to X-Ray. So what I'd like to do here is show you a little example of how this works. And what I've done is, instead of building my own application, I've used a common project in the Java space called Pet Clinic. It's a version of Pet Clinic that has an Angular front end and a REST backend. It speaks to a database. And then what it also does is I did add a little bit of code to have it call a Lambda as well. So for many of these languages, they have these instrument libraries, which I'm going to use here, that really simplify adding this to your application. As a matter of fact, in the Java space at least, if you use this, you don't have to make a single change to your application. It knows how to weave in the code in order to grab those metrics for you. You just have to include an agent on the command line. So I have done that to demonstrate this. So I have this Java application running here. And I'm just running the application with the Java agent, which is what this is. Oops. So this is a jar file I downloaded from OpenTelemetry. And then to configure it, I've done some system properties. So I wanted to grab traces, and I wanted to grab metrics in particular. And then I am pointing it at where my collector is running. Now I could point it at an OpenTelemetry collector, or in this case, I'm doing it to the Amazon distribution of the OpenTelemetry, so it knows about AWS. It's also a good practice to make sure you give it a service name, so we know what component in the overall architecture in which these traces are going, which one this applies to. So it'll be grouped under this name, anything going through this Java application. And then I've also said I don't want to collect logs. Maybe I have another way of collecting logs, so I can turn that off there. And then this is just the regular way to start a Java application. So I'll go ahead and start this up. It tells me right off the bat that it's using OpenTelemetry agent, collecting that information. While that's coming up, I'll point out two other things. I do have here I have the ADOT running, collecting the information, and I also have an Angular app running as well. So I have that collector running. This is generally how a collector works, is you have input data coming from your left. It's going to be received. It's going to go through a bunch of pipelines that you can configure, telling it what to do, and then it's going to export that. Now, it could export it to another collector. It could export it to a vendor product. It can export it to the AWS, CloudWatch, and X-Ray. And like I said, I'm using the distro for OpenTelemetry from AWS right now, so it's got those extensions to speak to the AWS components. You configure this with a YAML file. So this is what the YAML file looks like. And I mentioned that there are pipelines in it. So we have receiving on the far left side, we have a pipeline of processors, and on the far right-hand side, we have exporters. You can see in the bottom left under services where those pipelines are defined. I have two pipelines here in particular. I have one for traces. I have another one for metrics. So if we look at the receivers, I have a couple different receivers up here on the top left. I have them for OTLP, so they're all using the OpenTelemetry protocol. I'm enabling gRPC and HTTP, and I've specified what ports it should be listening on for those. And then down in the pipelines at the bottom, we have receivers. So we could have a number of receivers. So for trace receivers, we're using OTLP. But we can also listen to, in this case, the X-Ray protocol as well. And then we are just for metrics using OTLP. For the processors, we can do a number of things as it's going through the collector. So we can batch things up. We could transform data if it's not coming in the right format that it needs to be in. We could have rules that says throw some data out because we know it's not relevant, those types of things. And right now we just have a batch processor for traces, and we have another batch processor for metrics, how often, what size, those types of components. But there's a number of extensions that can be used here. Then in the pipeline, we tell the processors exactly which ones we're using. And then for the exporters, once the collector gets it, where is it going to send that information? And because I'm using the AWS distro, I can say I want it to export to X-Ray, to CloudWatch, to CloudWatch logs, and then again in the pipelines down below, I'm telling it for each individual type of information, where is it getting exported to. Now to make it easy for me to do demos, I have a Docker Compose that runs the collector from AWS that can be run as a Docker container. You can install it natively. There's a number of ways of running it. It's written in Go, so it runs on most platforms. It points to that configuration file and to the ports in which my application is going to talk to. So we already showed you how you can configure at least a Java application in order to talk to that. And once you have that up and running, you start doing things inside of your application. Inside of CloudWatch and X-Ray, you'll start to see that information come through. So let me make sure there's nothing else I want to hit before I switch over. Okay. The slides are available at that URL, and so you can grab those. I'll have this back up later. There's some resources that you might want to look at, but let me show you what this looks like when it's running. Okay, so I have this Angular application here. I have the OpenTelemetry collector running as the distribution, collecting the information. I have a Java application running as well. And as I navigate through this application, it's collecting each of these requests and capturing it and sending it. So I can even do a post request, for example. All this is getting captured. When I'm hitting this one right here, this is where I'm actually calling a Lambda as well underneath the covers. So if I go to AWS's dashboard and I go to the trace map, we can see here all the components, and we can see that when the client calls our Java application, this is that service name I pointed out before, the Spring Pet Clinic REST, it's making a call to something remote, which happens to be the database, and it's making a GET request that's remote, which happens to be a call to the API gateway, which is calling my Lambda underneath the covers. I don't have all my propagations quite configured properly. If I did, you would see this row right here as well, if everything was configured right. Now what I can do is I can select one of these, like my Java component. Now this Java component could have been running on-premise, inside of ECS, inside of an EC2 instance. That doesn't matter. You could even configure OpenTelemetry for a Lambda. Now that one I start to think, it's already coupled to AWS, so why would you need to do that? Why not just use one of their other libraries? But you could. And if I look at traces then, I can see here are those calls that I just made a couple minutes ago. I could drill down into one of these requests. They have a new UI that's not always rendering this stuff properly. And I can see down here that the request came in, it went to the repository component. Inside the repository component, it did a select statement in the database. If I wanted to see what that select statement is, I could come over here and look at the metadata and the SQL. I don't know why that one's not showing up. Usually it's, maybe I need to go one level higher. There it is. So it's showing me, it actually called the method find all on that particular component. I need to go one lower. This is probably where it is. If I go one lower here, I can see here's the select statement that was actually executed when that request was made. I can see the durations and where all the time was spent. Most of the time was spent calling that Lambda and getting the result back from the Lambda. So now I can start to optimize my application. If there are failures for some reason, if half of my calls failed here, this circle would have some red on it, and it would show you a percentage of how many of those calls had failed. So that shows you the traces and what it would look like. Meanwhile, it was also capturing the metrics. And we can see right up here, there's a custom namespace, and it's named after that service name that I gave it. And I can drill in and look at a number of different metrics related to my application. One of the things that we are often concerned about in a Java application is garbage collection. And we can see right here that we have information about the garbage collector, which we can put up on the dashboard and see how our application is performing from those lower level metrics as well. So, any questions? Yes?
Yeah, I've got quite a few questions, so I'm just going to try to ask some time. I'm going to try to just touch on. So I think your first, second, third slide, you talked about, being able to deploy this maybe to an end user or feeding it from an end user.
Yes.
So, healthcare space, if you're talking about PHI data, if you're talking about a clinician, if you're talking about somebody that's providing healthcare, I didn't see HTTPS calls. I only saw HTTP or what it looked like through text calls.
Sure.
So they send it to a collector in AWS from the user side to be able to get that data encrypted in transit, or is that one of those things where you just want to keep it local?
No, of course it can run with HTTPS. I didn't go through all the process of creating certificates and stuff, but it absolutely can run under HTTPS. Yeah. I don't see any other questions, so do you have more?
What are the deployment capabilities within AWS? Like, did you deploy, and one of the things that I think, because seeing this, and my mind's going 100 different ways of places where this could be incredibly useful, right? And that's I guess, part of my question, because we have clinician calls into middleware is pulling X-ray images, pulling prescription information, pulling, all of these different tangential things, right? And so sometimes we don't even know what the application is for, right? It's one of those things we talked about in one of the morning sessions. A system starts out very simple, and then you bold one, and you bold one, and you bold one, and you bold one, and then you're like, I don't even know, right? I don't know where this is going or what this is calling. I know it works. So are there ways that we can, even deploy this at, say, a VPC level, look at VPC flow logs, see what it's calling out to when it's building your trace? What are the thoughts and limitations of that?
Yeah, so the OpenTelemetry is very flexible in that way. So you can have these agents that are running close to your application, like inside your VPC, and then you can have a larger collector that would collect those and forward them on. So you could have a lot of little ones going to a bigger one, and then ultimately it's going to your vendor. So in AWS, if you're using all AWS, it probably doesn't hurt to have this go straight to AWS because it's all presumably running close. Now, if you wanted all your metrics in one common region and you were running the application across regions, that would be another good reason to have one of those small agents running in your VPC and then collect it and deploy it to a particular agent. But there's a lot of flexibility. It can be run as a container, it can be run as a sidecar, it could be run as an application running on an EC2 instance. Your deployment model is very flexible.
Can I get a third? We have time for another question?
Yeah, or we can, over drinks or in the hallway, I'm happy to answer questions as well.
Just one more for here, I think that might be interesting. What is the difficulty of deploying this at a client site? Because a lot of times, we have technical knowledge here.
Sure.
But then we've got an end user, and you're talking doctor, nurse, PA, whatever, right?
Yeah.
And you're saying, hey, put this on your machine.
So
as simple as like I could write something that they can click and execute, or.
So hopefully I didn't mean to confuse it by saying you could deploy it to the end user is not going to run this.
Okay.
So if you have a web application, you can use the JavaScript libraries embedded in your Angular or React application that would call back to your server, your agent running on a port that is accessible to it. It would collect the data along with your backend and aggregate it all together in whatever vendor product you're using. So you are collecting metrics from the end user, but they're not running the agent themselves.
Right, so it's just whatever their response time is at the Java endpoint itself.
Well, but the advantage is because it's a library inside the JavaScript, you would know from the JavaScript to, in my case, a Java backend, you could measure that time and distance as well as it can capture rendering times and other types of metrics you might want to capture on the front end as well, because that's one of the most difficult. If you have exceptions or errors in the browser, you usually don't get those. If you configure this properly, you can grab some of those will become logs and flow through the same system and end up in CloudWatch right beside the database call that failed too. So you can do more investigation of, and it will have the same trace ID. So you'll be able to tell this log absolutely was associated with this database failure or other problem. Yep. So there is another speaker coming, so I will take any other questions out in the hall.